Space is vast, billions of stars, even more planets, and endless mysteries. For astronomers, it's a cosmic playground. Every time we look up, we find something new and unexpected. Recently, astronomers discovered a supersized planet orbiting a tiny star, like finding an elephant in a kitten's basket. This giant planet and its small star are challenging everything we thought we knew about how planets and stars form. When discoveries don't fit our understanding, it's a chance to learn something profound. This cosmic odd couple is opening a new chapter in our knowledge. Let's dive into the story of this tiny star, its huge planet, and why it's making scientists rethink how planets are born. Get ready to be amazed by the wonders of the cosmos. Meet TOI 6894, a small, dim M-dwarf star that quietly resides in the vastness of our galaxy. Unlike the bright, easily visible stars that dominate our night sky, TOI 6894 is faint and subtle, almost hiding in plain sight among the cosmic tapestry. Its reddish glow is barely perceptible even through powerful telescopes, making it a true hidden gem in the universe. This elusive star is located about 240 light-years from Earth, a distance so immense that even light, traveling at 300,000 kilometers per second, takes more than 2 centuries to reach us. Imagine the vast stretches of space separating us from TOI 6894 and how much the universe has changed in the time its light has been traveling our way. M-dwarfs like TOI 6894 are actually the most common type of star in our galaxy, outnumbering all other stars combined. Yet, because they're so faint and small, they often go unnoticed, blending into the background of the night sky. These stars burn their fuel slowly, living for billions, sometimes even trillions of years, making them some of the oldest and most enduring objects in the cosmos. Now, orbiting this tiny, unassuming star is TOI 6894b, a gas giant planet that's similar in size to Jupiter, or perhaps even larger. It's a massive world, swirling with clouds and storms, circling a star that's barely bigger than Jupiter itself. The contrast between the planet and its host star is truly astonishing. To put things in perspective, Jupiter is so enormous that over 1,300 Earths could fit inside it. Now, imagine a planet of that scale, or even bigger, orbiting a star that's not much larger than the planet itself. TOI 6894b is truly colossal, and its presence challenges our understanding of how planets and stars form together. What's wild is that such a huge planet is orbiting such a small star. The size difference is so extreme that it almost seems like a cosmic joke, a planet nearly rivaling its own sun in size, locked in a gravitational dance that defies what we usually expect from planetary systems. Usually, big planets are found around big, bright stars, while small stars like M-dwarfs tend to have small, rocky planets, if they have planets at all. The rules of planetary formation suggest that a tiny star shouldn't be able to gather enough material to form such a giant planet. This pairing is like a chihuahua walking a St. Bernard. It's a delightful mismatch that makes astronomers do a double take, and it's a perfect example of how the universe loves to surprise us with the unexpected. Finding a giant planet around a tiny star is extremely rare and defies expectations. It's the kind of discovery that makes scientists question what they thought they knew about how planets and stars form and evolve together. This discovery is giving scientists plenty to investigate. They're now re-examining their models of planet formation, wondering how such a massive planet could have formed around such a small star and what this means for the diversity of planetary systems in our galaxy. It's a cosmic odd couple that's rewriting the rules of astronomy. TOI 6894 and its giant companion, TOI 6894b, remind us that the universe is full of surprises, and every new discovery has the potential to change our understanding of the cosmos. What a discovery! Why is this such a shock? To understand why astronomers are so baffled, we need to look at what they've learned from decades of searching the skies. Over the years, scientists have discovered thousands of exoplanets, planets orbiting stars beyond our solar system, and they've noticed some pretty reliable patterns. Generally, the rule has been simple. Big stars tend to have big planets, while small stars usually host small, rocky worlds. This makes sense because the amount of material swirling around a newborn star, the protoplanetary disk, sets the stage for what kinds of planets can form. Our own solar system is a textbook example. We have small, rocky planets like Mercury, Venus, Earth, and Mars close to the Sun, and then farther out, the gas giants, Jupiter and Saturn, dominate, with their massive sizes and thick atmospheres. So, when astronomers look at stars much smaller than our Sun, like red dwarfs, they expect to find only small, rocky planets. These stars just don't have enough raw material in their disks to build anything much bigger. But then came the discovery of Wyze 6894b, a planet as big as Jupiter orbiting a star that's only a fraction the size of our Sun. This completely breaks the pattern astronomers have come to expect. Imagine walking into a garden and seeing a giant watermelon growing on a tiny bonsai tree. That's how strange this cosmic pairing is. It's so unexpected that it almost seems impossible. The star, being so small, shouldn't have had nearly enough dust and gas in its disk to form such a massive planet. According to current theories, there simply isn't enough building material available in these environments. This discovery throws a wrench into the neat, orderly theories scientists have developed about how planets form around small stars. It's forcing researchers to go back to the drawing board and rethink what's possible. But in science, surprises like this are actually a good thing. They remind us that the universe is full of mysteries, and that our understanding is always evolving. Each time we find something that doesn't fit, it's an opportunity to learn more. Every new mystery pushes scientists to ask deeper questions, develop new theories, and expand the boundaries of what we know. It's these puzzles that drive scientific progress and keep the search for knowledge exciting. This giant planet orbiting a tiny star is more than just an oddity. It's a cosmic puzzle that could change our understanding of how planets form and what kinds of worlds might be out there. Science thrives on these cosmic surprises, and with every new discovery, we get a little closer to unraveling the secrets of the universe. To unravel the mystery of how planets come to be, let's start by exploring the classic theory that astronomers have relied on for decades, the core accretion model. This model is like a cosmic recipe, guiding us through the step-by-step process of planet formation. Picture a young star, newly ignited, surrounded by a vast spinning disk of gas and dust. This swirling disk, known as a protoplanetary disk, is the birthplace of planets. It's a chaotic, dynamic environment filled with the raw ingredients for building worlds. Within this disk, countless tiny dust grains begin to collide and stick together. Over time, these grains form small clumps, which gradually grow into pebbles and then into larger rocks. It's a slow but steady process, driven by gentle collisions and the sticky forces between particles. As these rocks grow larger, they become planetesimals, miniature planets, often just a few kilometers across. These planetesimals have enough gravity to pull in even more material, accelerating their growth as they sweep through the disk. Over millions of years, planetesimals collide and merge in a cosmic dance, sometimes shattering, sometimes sticking together. Eventually, the largest of these bodies become protoplanets, embryonic worlds on their way to becoming full-fledged planets. If a protoplanet's core grows massive enough, about 10 times the mass of Earth, it gains the power to pull in vast amounts of gas from the surrounding disk. This is a crucial turning point, as the growing planet begins to build a thick, gaseous envelope. This is how the gas giants like Jupiter and Saturn are born. First, a solid core forms, and then it's wrapped in a massive, swirling atmosphere of hydrogen and helium, making these planets the giants of our solar system. But this entire process depends on having plenty of material in the disk and enough time before the gas is blown away by the young star's intense radiation. If the ingredients run out too soon, the planet can't grow big enough to become a gas giant. In many ways, it's like a cosmic construction project, slow, methodical, and requiring just the right conditions. Each stage builds on the last, and a single misstep can halt the process entirely. This is the standard recipe for making planets, a tried and true method that has shaped our understanding of how worlds like ours and the giants beyond come to exist in the universe. But Wyze 6894b doesn't fit this recipe at all. Small stars like Wyze 6894 have small disks with less material, so only small planets should form. It's like trying to bake a giant cake with just a spoonful of flour. There shouldn't have been enough material or time to build a giant planet. Yet here's Wyze 6894b, a Jupiter-sized planet around a tiny star. This suggests we might need new ideas about how giant planets can form. When discoveries break the rules, scientists get creative. One new idea is disk instability. If the disk is massive and cool enough, it could collapse quickly to form a giant planet. Maybe TOI 6894's disk was unusually massive or efficient at gathering material. Or perhaps the planet formed farther out and migrated inward over time. Scientists are running new simulations to test these ideas. Each possibility could help explain how a giant planet ended up around such a small star. It's a cosmic mystery in the making. Finding TOI 6894b isn't just a curiosity, it's a game changer for exoplanet research. M-dwarfs are the most common stars in the galaxy, so if they can host giant planets, there could be many more out there. This discovery could increase the number of known gas giants and reshape our search strategies. Astronomers may now look for giant planets around small stars, not just big ones. Each new system helps us refine our models of planet formation. Studying oddballs like TOI 6894b helps us understand our own solar system's place in the universe. Every discovery adds a crucial piece to the cosmic puzzle. How do scientists find planets so far away? They use clever techniques like the transit method. When a planet passes in front of its star, it blocks a tiny bit of light. Telescopes like TESS can detect this dip. Another method is radial velocity or the wobble method. Planets tug on their stars, causing tiny shifts in starlight. These techniques reveal a planet's size, orbit, and even its mass. Sometimes scientists can study a planet's atmosphere by analyzing starlight that passes through it. This lets us detect gases like water vapor or methane, chemistry from light years away. Space detectives are getting better at uncovering the secrets of distant worlds. Space is full of wonders, and every new discovery opens more questions. TOI 6894b reminds us the universe is more diverse and surprising than we imagined. Each oddball planet helps us piece together the story of how solar systems form. Scientists will keep studying TOI 6894b, using new telescopes and techniques to learn more. The adventure of discovery never ends. Every answer leads to new mysteries. Staying curious and asking questions